Hello, colleagues. It's very great to see you, all of you, and so many familiar faces are seeing today. And let me introduce myself. I'm Rūdolfs, and today I'm not going to go into the details of how we are using the GIS in our daily life, but I will explain from the management point of view what kind of projects we are delivering. So afterwards and at the end of the day, we could deliver this mega project that we are calling Rail Baltica. So very briefly about myself. I'm GIS specialist in Rail Baltica project. I joined this project in 2021. And fun fact about myself, I have a double degree, master degree in both Vilnius Technical and Riga Technical University. And in GIS industry, I'm since 2010. Yeah, okay, maybe it's not so much, but comparing to others, but it's also not so less. I'm quite certain that all of you know what exactly is Rail Baltica, but maybe for those who are not living in Baltic countries, I will just very briefly remind that Rail Baltica is 870 kilometers long greenfield railway infrastructure, and our target is to connect all three Baltic countries to the railway, European railway network system. And we are designing that the future speed for the passenger trains will be 249 kilometers per hour, and for cargo trains it's going to be like 120 kilometers per hour. And of course, if we are looking on those numbers, that we are planning that from Riga you will be able to reach Tallinn or Vilnius in less than 2 hours. And comparing approximate 4 hours by car or by bus, I would say it's quite impressive. Right now, our global project is in master design for priority stage that it's all nearly completion. So we can assume that our project has reached this maturity level where we are receiving 3D data. And previous speaker, Philip, already mentioned a lot of things regarding 3D data and how we are using them, and I will explain a few more details later. And currently, we are expecting that this year more than 100 kilometers will be under construction in whole Baltic countries. Right now, there's a final stage for consolidated material procurement, which is one of the largest procurements in Baltic countries. So it means that there's one procurement for all three countries where those construction materials will be delivered. And also the electrification, control, command, and signaling subsystems for the whole mainline is also ongoing, the procurement for all those systems. And regarding the delivery program 2030, maybe some of you have heard of it, the project facing final alignments with all three states are still ongoing and hopefully will be aligned soon. And investment cost updates are ongoing, and it's expected to be finalized this year, as well as cost-benefit analysis and new generation business plan. And of course, interinstitutional project delivery setup improvements are also happening at the moment. In GIS team or our department, we are involved in 4 priorities in our global project. Of course, in the project, in total, there are more priorities, but today I would like to focus on 4 of them, where our involvement is quite significant. First of all is design and planning. This probably is most obvious topic. Then is construction works. Third one is railway subsystem development. And last but not least is securing of finances. As I mentioned, as Philip told previously about 3D data and model usage in our project, we are gathering together all this 3D data, and we are putting all those designed files into the one database, as we are calling single source of truth. This task is very important, not only for putting together all this information, but also by having a single source of truth database, we can provide the same information in user-friendly environment for all other colleagues who probably are not technical experts and who are not using quite advanced BIM softwares. Therefore, nice visualizations and user-friendly environment such as GIS is very, very useful for making better understanding in our project. And as you can see in this picture, I would like just to add that those persons who are not using the BIM softwares can very easily to use our GIS platform just to reviewing the clash errors between the interfaces or different deliverables or 3D files. And our mainline, as I mentioned, is 870 kilometers, and it's split in so many sections, and right now I don't remember exactly how many, but all those files are delivered separately, and we have to put everything together. And of course, if we need to review it one by one, sometimes it could be quite hard and difficult. Therefore, we have this one common platform. And right here on the picture of your right, you can see our progress of processing all those 3D data sets. And I would like to say that right now we have approximately 50% of our mainline is covered with 3D data. In my opinion, it's quite good result. Of course, no one has rejected or canceled the 2D data. And right now on the screen, you can see the photo or screenshot from one project, what we have together with Latvian implementing body Eiropas dzelzceļa līnijas, where Eiropas dzelzceļa līnijas is performing very important task. They are dealing with land acquisition, and together this is two enterprise collaboration, how we can integrate two completely different systems and out of both systems we can create one good visualization. This project is very important for both enterprise, so they can do their daily work in their systems, but we as a project coordinator, we can track what is the status of acquired land plots, and if all those land plots are available for the construction works, because without available land we cannot build anything. Of course, we are also interested in building permits, and building permits sometimes refers also to the submission packages, what we are receiving from the designers, and also not only for the technical teams, but also for the project planners, financial teams and others. It's very important to know what kind of building permits or submission packages we are receiving and what kind of construction objects falls within into this area. And for the building permits we are using like very regular polygons which describes approximate area where those construction objects are within. And therefore, with such kind of quite simple dashboards, we can track very, very important information. Quite recently, we start to work on one very hot topic for ourselves. Together with our transport economists, we are developing a transport demand models, where transport economists are doing their math, they are calculating the volumes of cargo, they are calculating what will be the estimate passenger flow on each of the sections, and GIS is helping them to provide a platform for the visualization, for the geospatial object, because all this mathematics has to be shown somewhere, and all this result should be accessible in very easy and understandable and user-friendly way. And of course, those projects I mentioned, not the only ones. We have dozens of projects regarding the design or planning, which helps our colleagues to do their daily tasks. We have geodesy maps where we are having all 3 Baltic countries' geodesy networks at once. Our colleagues can estimate and plan approximate locations for the new local geodetic networks. We have logistics maps where our logistic colleagues are planning where all those construction materials will be stored and how it will be delivered to the construction sites. Paper map, they are still common in 21st century. We are doing it for the presentation materials. In every room in our office we have the paper maps, and it looks like there will be required in next years as well. And of course, quite recently we released an updated version of our public map, and it's available on our homepage, realbaltica.org. So you are very welcome to visit this homepage and check it, how does it look like. And and right now, as I mentioned, we have reached this maturity level in project where we are moving from design to the construction stage. And as an enterprise, we are not obliged to perform construction supervision tasks, but we are setting some requirements, and it's very important also that we can use and work with this construction supervision data. And therefore, we are investigating and testing several options. How can we process in most efficient and the best way 3D LiDAR data, orthophotos, 3D models, and how we can combine it together, because this data amount for all this mainland it's a huge, and it takes a lot of resources from human resources point of view and also from the technical ones. So this is also one topic that we are working regarding the construction works. Another thing, we are helping our colleagues from systems and operations team to set up a platform where they can compare different kind of data sets which is coming from external sources. In this case, you can see a possibility where we can connect to existing local power grid. So our colleagues are having a platform where they are investigating those possibilities, those locations, where approximately we can connect to the grid and add our systems. And when it's going to be done, all this information can be included and as a supplement for the procurement attachments. And of course, regarding the finances, in most cases are thought of information that cannot be located on the map, but actually finances as other data could be quite easily located, and it also has some kind of geospatial component. And also quite recently we start to work on different maps which represents financial information. First of all, we are receiving the European money, like European fund money. In this case, we are talking about the CEF finance. And we have to locate it on the maps, and also this is going as a report, as attachment to the reports where we are spending this money, in which section, how many we are spending, and so on, and what kind of objects we are building for that money. And also the estimated capex information. This is what we are working on and trying to visualize on the map where exactly this money is going. And as well as project complexity, because even Rail Baltic is a mega project. Some parts are more difficult to build and manage, and some parts are a little bit easier. And that's why it's important to have this vision of the complexity in different sections. And of course, as I mentioned, finance allocation is important. But why it's important? It's important that we are avoiding of double financing. And of course, Europe is also tracking that we are not spending or applying for several grants for several funds to do the same task twice. And to avoid of that, we are trying to do it before we are submitting those finance requests to European Union, and we are trying to eliminate all the errors and all those possibilities before we are applying. And afterwards, at the end of the day, it's all about the support for the project control. And as you can see in this bottom of the slide, we can split the 3 main target audiences for our products. The one and the first is technical teams. Second are decision makers, and third one is general or public. And in opposite side, we have different teams who are working with those data or matters or questions and topics. And we as a GIS, we are meeting somewhere in the middle, because we are not only showing and visualizing the data that we have, but we are also supporting our colleagues to set the correct requirements for the databases or for the technical questions. And yeah, as a GIS, we are connecting all those parties together, and we are doing to make our project more efficient by saving some money and something like that. In a nutshell, that's it. Thank you for your attention. There are few of my colleagues also in the audience, so feel free to catch us if you have some technical questions. But yeah, thank you.